Quiz example, Bhutan e-learning program welcomes all the children to this lesson. I am Pavitra Bhatrai and I'll be taking a physics lesson for Key Stage 5, that is for class 11 and 12 students. Today I'm going to teach you all about simple harmonic motion. Now under simple harmonic motion, I'll try to focus more on maximum velocity . Now, why do we need to learn simple harmonic motion? In this world of oscillation, the study of simple harmonic motion plays a very important role because simple harmonic motion is an oscillating motion which connects to many real-life situations like swinging of pendulum, spring and mass, and the vibration of molecules. And there are many more examples which we are going to learn in the later part. I'm sure you all must be very fond of music, but have you ever wondered how do we get to hear music? What is the in-between process that helps us to hear music? Another example could be like when we go for a ride, why don't we experience the bumpy rides? Or else, why all the vehicles comprise of shock absorber? Next example could be why pendulum and swing repetitive motion. Fourth example could be how does the transfer of heat takes place in case of solids. So all these questions are answered by a common phenomenon known as simple harmonic motion. So here I have a picture whereby you can see that how the motion appears in case of simple harmonic motion. It is a back and forth motion, or we can call it as to and fro motion. Example I have cited here is that of swing and pendulum. What is simple harmonic motion? Simple harmonic motion is a special type of periodic motion in which a body executes to and fro motion or back and forth motion about its mean position under the influence of restoring force. Now let's look into this picture. I have a picture of simple pendulum here. So what happens here? I have taken out two terms like periodic motion. What do we mean by periodic motion? So periodic motion means any motion which repeats at regular interval of time. So in case of simple pendulum, we can very well see that there is repetitive motion. Now, another term I have used is restoring force. What do you mean by restoring force? Now, if you want to define restoring force properly, it can be defined in this manner. When we disturb a body from equilibrium state, it tries to come back to its initial position. So the force which tries to bring the body back to its mean position is what is referred to as restoring force. So in this picture, you can very well see that the restoring force direction is clearly indicated by the arrow. Okay, now here I have an example of block and spring system which we can consider under simple harmonic motion. You can look at the picture. So you can see how the path is being traced. In case of simple harmonic motion, when we have to and fro motion, the body executes a simple harmonic motion, and the path you can see here, it's purely sinusoidal in nature. Now have a look properly, because this nature of path we are going to introduce in the next part of the lesson. So you can very well see the path. The path traced by the body executing simple harmonic motion is purely sinusoidal in nature. Okay, with that concept, now let's move on to the next subtopic, that is how to find out the velocity of a body executing simple harmonic motion. The displacement in simple harmonic motion is given by the equation x equals to e cos 2 pi ft or x equals to a sin 2 pi ft. Remember that we use the letter x to resemble displacement. Okay, there are some other letters which we have used, and each letter has its own description. Likewise, you can see in the equation that we have used A. A resembles the amplitude. In case of simple harmonic motion, F resembles frequency, likewise T resembles time period. So remember that in this displacement equation, when we use the letter X, X simply means the displacement of a body executing simple harmonic motion. Okay, what do you mean by displacement? Displacement is the distance of the particle from the mean position at any instant of time while executing simple harmonic motion. Okay, now we know that displacement is the distance traveled by the body with respect to mean position on either side of the mean position. So in this respect, we can have a positive displacement as well as a negative displacement. Now let's move on to next term, amplitude. What do you mean by amplitude? The maximum displacement is what is referred to as amplitude. Let's read the definition once again. Amplitude, the maximum displacement of a particle on either side of its mean position, is known as amplitude. Its symbol is A. Okay, now let's go to the third definition, that is frequency. So what do you mean by frequency? The number of oscillation made per second, or the number of repetitive motion per second, is what is referred to as frequency. The symbol we use for frequency is F, small letter F, and the unit we use is hertz. The fourth one is time period. What do you mean by time period? Okay, the time taken to complete one oscillation or one repetitive motion is what is referred to as time period. The symbol we use here is T. Okay, now let's try to view a figure. Let's have a look at a figure where we try to explore what is meant by amplitude as well as what is meant by the time period. Okay, in this figure, you can have a look here. We have a complete cycle, a rise and a fall. That simply means the to and the fro motion. A complete cycle, in order to complete one cycle, one full cycle, that is what is referred to as the time period. Now look at the amplitude part. In the figure, it's clearly shown that it simply resembles the maximum vertical distance. So I hope now you know how to level the amplitude and how to identify a complete cycle. Okay, now let's have a look at the second figure. In the second figure, I have given you two different types of waves where we can cross-check the amplitude, the nature of the amplitude and nature of the cycle. In the first wave diagram, we can see that the amplitude is much greater than that in case of the second figure. Okay, one more definition we would like to add up here is that of angular frequency. When we are dealing with the displacement equation, time and again we may come across another term that is referred to as angular frequency. What is angular frequency now? Angular frequency is related to periodic motion. That means when a body comes back to its initial position after completing one cycle, then that is what is referred to as angular frequency. So how to measure the angular frequency? So in one complete cycle, you know, we can either express in radians or in degrees. So in one complete cycle, you all know that the angle maintained is 360 degrees. So if you want to find out the angular frequency, the formula is simply given by 2 pi over t. Okay, after having learnt about angular frequency, time period, amplitude and frequency, now we are in a position to understand what is meant by maximum velocity. In order to derive the maximum velocity, let's follow these steps. Okay, now let's learn to derive the equation for maximum velocity. In order to derive the equation for maximum velocity, we need to know the displacement equation first. So do you all remember what is the displacement equation? Well, okay, let me remind you once again. The displacement equation, we have used two equations here, but for our convenience we are going to use x equals to a cos 2 pi ft. Remember, we have used two equations, that is a sin 2 pi ft and a cos 2 pi ft. Okay, so once again keep in mind we are going to use a cos 2 pi ft. Now let's see how we can derive the velocity equation, that is maximum velocity equation. Let's follow this step in order to do so. The velocity of a body executing simple harmonic motion is given by the rate of change of displacement. Now to make it short, how we can find the rate of change of displacement? We can find rate of change of displacement by simply finding the derivative of displacement. Okay, it must be very new to class 11 students. So please keep two formulas in mind. That is, when you find the derivative of cos, it is negative sign, and when you find derivative of sine of any angle, it becomes cos. Hope you will be able to remember. Okay, now let's go back to the mathematical statement. Okay, so that means we can find velocity by taking derivative of displacement, which can be written mathematically as v equals to dx over dt. Please replace x with the displacement equation. Once again, displacement equation is given by a cos 2 pi ft. Okay, now what is derivative of cos? It is negative sign. Here remember that a is the amplitude and it is a coefficient. So what will happen when we take the derivative? Coefficient remains as it is. So therefore, velocity equals to negative a sine 2 pi ft times 2 pi f. Now you must be wondering from where we have got this 2 pi f. Okay, so this 2 pi f we simply get by taking derivative of trigonometric function. The rule under derivative is that first take derivative of trigonometric function, then without trigonometric function. Hope you will be able to remember. Okay, after combining all this term, what is our final result? Let's have a look at it. Okay, therefore, our final equation reduces to negative 2 pi f times a sine 2 pi ft. Okay, here the key point is what we need to remember. We need to remember what is that coefficient known as. Here we have used the coefficient as 2 pi f times a. So that is what is known as velocity amplitude or maximum velocity. Please keep in mind we can either write it in words as maximum velocity or we can write as Vmax. V stands for velocity and maximum, for short form we can use that max. So hope you have learned how to derive the velocity equation. Once again, please keep in mind it is simply rate of change of displacement. So we can find it by taking derivative of the displacement equation. Okay, now next let's try to find out the maximum acceleration equation. So in order to find maximum acceleration equation, it's very important we know the result of velocity equation. So in the previous equation we have learned how to derive the velocity equation. We are going to use the same equation to derive the acceleration equation. The acceleration of a body executing simple harmonic motion is given by rate of change of velocity. So now you are pretty clear how to find out the rate of change of velocity. Again, we take the derivative. This time we take derivative of velocity. Remember, velocity equation is ready. That is equation number 2. Okay, in case if you have forgotten, let's go back and try to see what was the equation. So the velocity equation is given by v equals to negative 2 pi f a sine 2 pi ft. Now what we will do is we will try to take derivative of the velocity equation. Okay, let's have a look here. So acceleration is given by the mathematical equation as dv over dt. So replace the velocity equation in place of v and try to find the derivative. make sure you remember what is the derivative of sine. Remember, derivative of sine is cos, but the negative sign remains intact. Okay, and one more step you need to remember is, first take derivative with respect to trigonometric function, then without trigonometric function. So after combining all the terms and after taking derivative, the final result that we get for acceleration is, we get the acceleration equation as negative 2 pi f the whole square times a cos 2 pi ft. Okay, so here the coefficient part. This coefficient part is what is known as the acceleration amplitude or maximum acceleration. So hope it is clear how to derive velocity, maximum velocity equation or maximum acceleration equation. These equations are very handy in solving numerical problems. Okay, let's have a closer look at this equation number 3 and the simplified version of equation number 3. In this equation number 3, you will find something common. Let's have a closer look. Can you look at the highlighted portion? A cos 2 pi ft reminds us of something. It is nothing but the displacement equation. So now replacing the displacement equation back in equation number 3, what we get is a simplified version of maximum acceleration equation. So here the final equation we get is acceleration equals to negative of 2 pi f the whole square times x. Now this equation has a greater meaning. You need to understand that acceleration is directly proportional to the displacement, but the negative sign indicates that it is directly proportional to displacement but in reverse direction. Okay, now we will learn to plot a graph for this situation. We have discussed displacement, we have discussed velocity, how to derive the velocity equation. We have also discussed on how to derive the acceleration equation. Now after having learned this, let's see how it varies with time. Now in order to do so, I would like to show you a simple demonstration based on simple harmonic motion. Okay, in order to plot a graph, I would like to show you a small demonstration on simple harmonic motion. Okay, this is a simple model of a simple pendulum. Now let's see how it functions, and let's try to connect on how to plot the graph based on the motion of the bob, pendulum bob. Okay, at equilibrium, right now the bob is at rest. That means this position is considered to be at the mean position. Now let's displace the bob at certain angle. Okay, now you can see that at this point the displacement here is maximum. Let's consider that this displacement is maximum. And what about the velocity at this point? The velocity is 0. Let me leave the bob. When I do so, the bob traces the path. So in this motion, you can see that the bob traces to and fro motion. So what happens in the initial stage, velocity is 0, but as it moves towards the mean position, it increases. Now we have learned a connection here. Acceleration of a body executing simple harmonic motion is directly proportional to displacement, but in reverse direction. So if the amplitude is highest, what will happen to the acceleration? It will be minimum. If amplitude is maximum, the acceleration will be minimum. So at this point, when I leave the ball by maintaining at certain angle, what happens to amplitude? Amplitude is taken as maximum, velocity is 0, but what about the acceleration? Acceleration here is minimum. Let's have a look at the graph. Okay. You can see here in the graph, in the displacement time graph, initially the amplitude is maximum. So when I have displaced the bob is at maximum displacement. So you can see that at time t equals to 0, displacement is maximum. Whereas what about the velocity? Velocity it was 0. So at time t equals to 0, velocity equals to 0, but it increases gradually when it moves towards the mean position. So in the graph, it's very clear that The motion of the bob is clearly indicated by the graph shown in the figure. Now let's talk about the acceleration time graph. We know that acceleration is directly proportional to displacement but in reverse manner. So if the displacement is maximum, what will happen to the acceleration? Acceleration will be maximum but in reverse direction. Hope it's clear how to plot the graph. Now towards the end, we have listed down few questions for you all based on the content of the lesson that we have learned today. Please try to work out at home. So hope you have learned from today's lesson. See you in my next lesson. Thank you.